What is going on, guys? Welcome to another chemistry tutorial, and in this lesson we're going to be breaking up the periodic table. And I know you guys have seen this before, probably never really paid that much attention to it, but in this tutorial we're going to learn how it's pieced together, what the heck it is, and why it's useful. So if you want to follow along with me, first of all, please make sure you're watching this tutorial in full screen on YouTube, 1080 resolution. So go ahead and change your settings, and then you're going to be able to see all these little numbers and words perfectly crystal clear. It's probably hard to see in that little YouTube box. So again, change it to full screen 1080p. And if you want to follow along with me, go to ptable.com. That's where I'm at right now. By far the best periodic table on the internet. And whenever I'm doing this tutorial, you're going to see why. So let's go ahead first and select one of these elements and learn what all these numbers are. The number in the top left is the atomic number. In other words, how many protons are in that element. In carbon, it's 6. There's always 6 protons in carbon. Now under that is the symbol. The symbol is pretty much the lazy or the shorthand version that chemists write the entire name because, hey, who wants to write the entire name all the time? We got things to do. We don't have time for that crap. Now under that is the name. In this case, it's carbon. Now under that, the number in the bottom left, in carbon it's 12.0107. This is called the atomic mass. Now I talked to you guys about atomic mass before, and I said it was the protons plus the neutrons. So why these numbers aren't even is it's actually the average of all the naturally occurring isotopes. So they took all the carbons, carbon 14, carbon 12, and they averaged them all together. So that's why this number isn't exactly even. So that's what all those numbers are. Oh, I missed two. And in the top right, you see a list of numbers. So if we go ahead and look at krypton, you would see 2, 8, 18, 8. This means these are the energy levels and how many electrons. It's pretty much the electron configuration. At the first energy level, there are 2. On the next one, there are 8. Next one, 18. In the next one, the fourth energy level, there are 8 electrons. So that's what all the numbers and symbols and words mean in each one of these elements. So you're saying, okay, so they found out all the elements on Earth and they threw them into a big random puzzle. Well, actually, this is pieced together in a very specific and very clever way. So let's go ahead and learn some terminology first. First of all, the horizontal rows are called periods. Now, if you look, we have 7 periods. 1, 2, 3, 4, 5, 6, 7. Again, the rows are called periods. In the columns, if you see we have 18 columns, these are called groups, or I'm going to be calling them families. People use them interchangeably. I guess they couldn't agree on a name, but they're more typically called families. And you have 18 columns or families. Now, aside from that, you can also see that this thing is color coded. And it isn't just because some kid decided to paint a bunch of colors on it. They're actually color coded in a very specific method, and they're actually grouped into different groups. So let's go ahead, and if we highlight metals, and this is why I love this periodic table. Again, ptable.com. Depending on what you highlight, different groups get color coded. So if we select the metals, they all show color and everything else is grayed out. If we select non-metals, everything else gets grayed out. So that's why I love this periodic table, because it makes my tutorial making like 100 times easier. So go ahead and hover over metals, and all the metals are going to be colored and all the other stuff in the top right is going to be grayed out. So all these metals have the properties that you might think. They're solid, they're shiny, they're good conductors of electricity. And if you notice, most of the elements on the periodic table and most of the elements in life are metals. So then we can go ahead and look at nonmetals. Go ahead and hover over that. Now the nonmetals are in the top right hand side of the periodic table, and these pretty much have the opposite properties of metals. They're poor conductors of electricity, they're brittle, some of these are even gases, those kind of light blue ones. So basically we have metals and nonmetals. But if you paid really close attention, you would notice that some of the elements in between them don't get lit up at all. We call those elements metalloids. And this pretty much is the in-between a metal and a nonmetal. They kind of share the properties of both metals and nonmetals. Basically, If metal and nonmetal had a baby, then these babies would be the metalloids. So, aside from that, let's go ahead and talk about something else. And that is that members of a family have similar properties. And remember, the families are the columns. So let's go ahead and pick on family number one. And whenever I'm talking about family, don't worry about hydrogen because hydrogen is only one atom. It's kind of different. So don't really worry about hydrogen. So the first column, or all the elements in family number one, are called the alkali earth metals. Now, whenever a chemical reaction takes place, they tend to lose one electron. And you're saying, okay, Bucky, why is this? Well, I know I didn't talk to you guys about chemical reactions yet, but I will in like 5 or 6 tutorials. Basically, whenever elements react with each other or try to combine with each other, they're always looking for full or completed energy levels. They're pretty much looking for even energy levels. So as you can see, that the electron configuration of all of these has one valence electron, one electron on the outermost energy level. So that electron, that valence electron, is really loosely attracted. There isn't much of an attraction to the nucleus. So that is why whenever these alkali metals combine in these chemical reactions, that valence electron is usually the first one to go. So again, just remember that in the first family, they always have one valence electron, and in chemical reactions, it usually loses that electron. In the family number one, goes by the name of alkali metals. Simple enough. So there's another family too, is goes by the nickname alkali earth metals. And if we look at the electron configuration for all of these, on all of these elements, they always have two valence electrons. So typically in chemical reactions, they lose these two valence electrons because remember the valence electrons are the ones that have the weakest bond with the nucleus. So those electrons are really easy to pluck off. Simple enough. And if we look at something like halogens, I guess would be a good one to talk about. If you look at the electron configuration, they always have 7 valence electrons. So whenever you have a halogen in a chemical reaction, they usually gain 1 electron because remember, I know I didn't talk to you about chemical reactions, but elements are always looking for a full or complete energy level. So they only need one more to complete that energy level. The third energy level has 8 electrons total. So that's why halogens usually gain 1 electron. And this last one I'll talk about, there are a lot of other transitional metals and stuff, but these noble gases are notable because they have full or completed energy levels. For example, helium, 2 electrons is all it can hold in the first energy level, it's full. Neon, 2 and 8, if you remember the electron configuration, at the first 2 energy levels, it goes 2 for the first one and 8 for the second one. So this one's completed too. So in chemical reactions, noble gases already are filled up. So that is why these are very, very unreactive elements. It's really hard to get these elements, these noble gases, to react with any other element in chemical reactions. And actually, for a long time, they thought that it was impossible. But then some guy came along and he figured, hey, it is just really hard to do, but not impossible. But that's a story for another day. For now, I'm my mouth is getting dry because I'm talking too much. So I think I need to go to Taco Bell and get some Frutista freezes or whatever. But anyways, that is all I have for you guys for this tutorial. So thank you guys for watching. Don't forget to subscribe, and I will see you guys next time.